I'm gonna just have to trust it and go with it. Come on. Let's try this again. There it is. Okay. All right. Yeah. So hopefully it should be streaming to our channel, so like we at least have a copy. Um, Let me see announcements. So we will probably have. We're gonna make a change to the lab. I'll be sending like I'll send I'll send some instructions, but I'm under the impression that we all should have access to what's called what is the thing called? Not Starfish. Alex, right? We should all have an Alex. Yeah, we should all have an Alex account. Why does that sound weird like that? We should all have an Alex account. And, does that mean? Um, and we can use that. So we're gonna use that for our lab, right? So I think we're gonna use Alex, and that'll count as 10% of our grade. So that'll be our lab, and so we're gonna be required to do at least 25 lessons a week. I think is how that goes. 25 lessons a week. So that's like about 5 a day. As far as, and so I'll send some instructions there, but you should already have an account. You should be able to log in and get going on that. Uh, yeah. I can't think of anything else pertinent. If you have a question, write it down or put it into the chat. I think I am going to mute everybody just so I can focus. And so to get my attention, you're going to have to use the chat. Okay. Yeah, we're going to add Alex. Yeah, I'm just going to go ahead and add that. That'll help out a lot. Yeah, that'll help. Okay. And so we can even take, I mean, if we finish like the presentation or our lectures early, because since we meet 4 times in a week, we have a lot of downtime. We can actually use class time to work on Alex, and I'll be available for questions. So the first priority in the week is to get through whatever the lecture is, and then the remainder of the week we can use for Alex, all right, or anything else that we wanna work on. Okay. So we don't have a lot of time today. We got about 20 or 25 minutes. But that Alex component is going to count as 10% of our grade. And the coordinator for that is Dr. Lamar, and she's going to send me a weekly report. Okay, so and I'll use that to factor that into our grade, overall grade. All right. So again, if you have questions, right now you have to use the chat. I think I disabled the unmuting ability, so you have to just use the chat for right now. Okay. So I'll just kind of monitor the time. We'll take some time to start on section 1.4. So yeah, we want to look at a library of functions, okay? And what do we mean by this? Some objectives here are to define linear functions, discuss important properties of functions. Oh, you said why are we using Alex now? We just need it, like just as a contrast, you know. Just as a contrast. Discuss important properties of functions, graph square roots and cube root functions, evaluate and graph piecewise functions, graph basic functions, and find the average rate of change of a function. Let M and B, and then let me go ahead and lock the meeting. Well, you would need the link to get in, but I'm still going to lock it anyway. This is well past that time. Okay. So let M and B be real numbers. Then the function f of x equals mx plus b is called a linear function. If m is equal to 0, the function f of x equals b is called a constant function. If m equals 1 and b equals 0, then we have what's called the identity function, right? So these kind of, how do we get enrolled in Alex? If you're not already enrolled, I'll send instructions on how to get enrolled. Just ask me again maybe on Thursday if you don't have if you haven't received instructions by Thursday. We'll get you set up. But if if this is like your first time being a freshman, then you should have got set up over the summer. If you're like retaking this course, or if you're just not a freshman, then you don't have access. We can get you set up. We can get you in there. So the first two basic functions that we have, the first is called a constant function. It's like y equals a number. It's just going to be a flat horizontal line through y equals whatever that number is. And then say the slope is 1 and our b, which is our y-intercept, is 0. Then we're going to have y equals x. It's called the identity function. Okay. So this next slide, if it ever shows. It says the graph of a linear function is a non-vertical line with a slope m and a y-intercept b, right? So the one on the left has a positive slope, right? So a positive slope for a line, as we trace the line left to right, it goes up, right? As we trace the line left to right, it goes up. If it has a negative slope as we trace it left to right, it goes down, right? So a constant function is like the one on the left. It's going to be a flat horizontal line through y equals whatever that number. That's when we have a slope of 0. And so the larger the slope, the more steep the line is. Again, this one on the right is called the identity function. This is like y equals x. All right, that's the identity function. So we're asked to write a linear function g for which g of 1 equals 4 and g of negative 3. So we have these two ordered pairs, right? And we're asked to write a function. Okay, a linear function. Okay. So the general form of the equation of a line is we can either do y equals mx plus b, or we'll do f of x equals, I'm just going to do mx plus b for right now. All right. Actually, for me, it's a little bit easier to see if I do y equals mx plus b. So we have a set of ordered pairs here, right? So we have g of 1 equals 4 and g of negative 3 equals negative 2, right? So this is basically saying when x is 1, this is saying when x is 1, y is 4, and when x is negative 3, y is negative 2, right? So then given these ordered pairs, I usually like to just automatically label them x1, y1, x2, y2, all right? Let me see how they're doing it. Yeah. So first, we need to find the slope, right? So the slope of a line, I think we talked about this before, right? y2 minus y1 over x2 minus x1. Okay. So that's going to be negative 2 minus 4 over negative 3 minus 1. That's going to be negative 6 over negative 4, which is a positive 3 by 2. So we have our slope. I don't know if I mentioned this before or not, but it's a good idea to have a formula sheet, right? Have a sheet where every time we come across a formula, we add it to our formula sheet. And so these are two formulas it's good to have, especially when talking about lines. I think we've mentioned the three equations, the three formulas whenever we're working with lines, all right? So I'm a fan of y equals mx plus b. We found the slope, and we have at least one point, so we can just use a point. So we're going to plug in the information that we have. So for instance, when y is 4, and the slope is 3 by 2, our x is 1. The only thing we don't know is b, right? So then if we solve, b is going to be equal to 4 minus 3 halves. You can use your calculator at this point. I'm going to do 8 by 2 minus 3 by 2 to give me 5 by 2. All right. So then the equation of the line is going to be y equals, or the slope is 3 by 2x plus 5 by 2. And then just to put it in the proper format, we're going to say g of x equals 3 by 2x plus 5 by 2. Okay. Again, if we have questions, we have to type them into the chat, and I'll address them there. I think I disabled the unmute for right now, so I can kind of focus. Style, come on. Okay. So if I don't see any questions in the chat, then I'm just going to kind of power through. Okay. So then we can verify that this works, right? I'm going to actually verify this in my calculator. I'm going to actually type in this function that we found in my calculator. Again, if anything isn't clear, you just have to get my attention with the chat. So let me open up my trusty, dusty, rusty calculator here. Okay. Reload and refresh. This looks good. So now in my y equals, we have this 3 by 2 times x plus 5 by 2. Right? We're saying that that's our function. So then we can verify that this works. So now, right here you see this clear button to the far right? To the left of that is a button that says VARS, VARS. I think it's short for variables. I'm going to click on that button. I'm going to go to the right to go to Y variables. And I'm going to click on number 1 for function and number 1 to recall that function that we just typed in. So now when x is 1, the output should be 4. And then when x is -3, the output should be -2. Okay? All right. So we verified that both of those ordered pairs work. We're going to hop back over this way. And let's see how did the notes do it. I felt like this was going to happen because of the way I did it. So this is definitely missing a bunch of symbols. First, find the slope. So this is missing, and I'll put it in like this color so you know that I'm filling in what's missing. This is m equals y2 minus y1 over x2 minus x1. This equals, that should be a -2 minus 4 and a -3 minus 1. So that's definitely missing those signs. Equals -6 over -4, but then finally we finish with a +3 by 2. I just didn't get a chance to do it the way I normally do it because of I was running late, so it's going to have those kind of errors. But that's okay. All right. So they use the point slope form. Let me kind of fill in what's missing from this as well. So this is going to be y minus y1 equals m times x minus x1, right? So that's going to be y minus 4. They just chose the other point. They chose that point there. We got the slope from the previous formula times x minus 1, right? This looks good. So then this persists. They distributed the 3/2, so there should be a negative there. Then you add 4 to both sides. 8 minus 3, and it should be a +5 right there. Okay. All right. Let's see the time. So we want to keep going for, if we did 10 minutes, 10 minutes is about right? Hey Siri, set a timer for 10 minutes.
Okay, 10 minutes and counting.
Okay. So then I think this all looks good. So then we have this notion of what do we mean by increasing, decreasing, and constant functions. So we're going to let f be a function and let x sub 1 and x sub 2 be any two numbers in an open interval a comma b contained in the domain. Somebody left. Let me see if I can read my users. It's okay. It doesn't really matter. Okay. So let f be a function and let x1 and x2 be any two numbers in an open interval ab contained in the domain of f. Then the symbols a and b may represent the real numbers negative infinity and infinity. Then we have the following. We said that a function is increasing. The simple explanation here is, in a graphical sense, as we trace the graph left to right, it goes up. Right? That's what we mean by a function is increasing. This is a formal technical definition of an increasing function. I do like that they have the open intervals. So whenever the first x value is less than the second x value, this implies that the first y value is less than the second y value, right? That's what we mean by a function that's increasing. Now, a simple explanation again, as we trace the graph left to right, it goes up, right? That's what we mean by increasing function. Similarly, we say the function is decreasing on the open interval. Whenever the first x value is less than the second x value, this implies that the first y value is greater than the second y value. That's what we mean by a function is decreasing on some open interval, right? the simple explanation is as we trace the graph left to right, it goes down, right? So, yeah, okay. And then we say a function is constant whenever the first x value is less than the second x value. This implies the first y value is equal to the second y value on some open interval on the domain, right? So long story short, what that means is we trace the graph left to right, it stays flat or constant. It doesn't go up nor does it go down. So that's what we mean by constant function. Okay. Let's do 5 more minutes. Maybe we might take it to the limit. So it says, from the graph of G, find the intervals over which this function is increasing, decreasing, or constant, right? So notice with this graph, as we trace it left to right, and you can type this into the chat, what is it doing first? As we trace it left to right, what is it doing? Is it going up? Is it staying flat? Or is it going down? Right? As we trace it left to right, is it going up? Is it staying flat? Or is it going down initially? It's increasing, right? So how far left does this graph go? It's increasing. What's the far left of the graph? How far left does it go? So the far left is negative infinity, right? And so it's increasing from negative infinity up to what's this x value? What's the x value here? It's increasing from negative infinity up to negative 2. Thank you, Mr. Dawson. That's awesome. Right? It's increasing from negative infinity. So we would say that this is increasing from... actually, let me do it like this. Come on. No. Oh, why is it not working? I shouldn't have to do that. Try one more time. There it is. Okay. We say that this is increasing from the far left was negative infinity. I wonder if that's a rule out there. If we could do math, oh my goodness, that would be awesome. It totally did not work. From negative infinity up until x equals negative 2 is increasing. And then from this x value to this x value, it's constant, right? So we say that it's constant. That's not constant. Constant from negative 2 to 3, right? So from negative 2 to 3, we say that it's constant. And then as we continue to trace from the left to right, we say it's decreasing. Nope. Why is it not working? Maybe I need to make it bigger. Down. Okay, we say it's decreasing from 3 to infinity. 3 to infinity. All right. So it's increasing from negative infinity to negative 2. So, and this is based on the domain. Like as we trace it left to right, it's going up from negative infinity to negative 2. Then it's staying flat from negative 2 to 3. And then from 3 to infinity, it's going down. All right. I think this is just reiterating what we just said. Okay. So I think I'm gonna just go ahead and stop here. I think this is a good place to stop. Yeah, it's actually a really good place to stop. So let me see. I'll just make a note. Let me see. Stopped here. What's today? Monday? September 14th. Let me allow you guys to unmute. Security. I'm gonna say you can unmute. Right? We stopped here on Monday. What's today? September 14th. Right? 2020. And then we're gonna pick back up here. So I'm gonna say start. That's not start. Start here. Tuesday, September 15th. 2020. Okay. You should be able to unmute yourself now. Anybody? So does this mean Pearson's going to be on hold? No. We're still doing Pearson. So we got Pearson and we have Alex. Alex is really our lab. Um, yeah. No, we need Pearson is our homework and quizzes and exams. That's how we're doing our main work. Alex is just Alex really kind of it. What Alex does, Alex is a little bit different system than Pearson. Pearson is relevant to what we're talking about in class, but Alex is there because this is a college algebra with lab. Alex is there to kind of fill in any gaps. So where I was trying to do it manually, Alex will find those gaps and suggest things for you to fill in to make sure you're thorough. So Alex is going to go through, like if you're weak in factoring, it'll give you factoring practice. The main thing is for Alex that we want to make our way through about 25 lessons a week. I know that's a good amount of work. I might be open to dialing back some of the work in Pearson, maybe, but right now let's just kind of work it and see how it goes. Yeah. If you're in this class has a lab component. We need to just pump it out, okay? Um, just go ahead and knock it out. Now, I'm open to if you feel like you don't need Alex. I think there is a way that you can maybe test out of it. Contact. You should be able to reach Dr. Lamar and ask her if there's a way that you can test out of it. Like we need it for the lab, right? But I think what is going to give you like a set of initial questions, and then it's gonna customize it based on your how you do, right? So that's why I was like I'm kind of curious to see and implement Alex. It's a little bit more dynamic, and it's a different system than Pearson, right? So we're going to use that for our lab, okay? But just keep asking questions. I think my Morehouse email is down, but just still use it. I'm working on getting that back to fully operational, okay? I'll go ahead and make a version of this available for everybody, and otherwise, guys, I'll let you go, and I'll see you tomorrow. Tomorrow we start at 3:50. Go ahead.
So we still like gonna be on Zoom while we in Alex or not?
Alex, you kind of do it at your own pace. Once we finish this lecture, you can actually work on Alex during class time, right? So today we stopped at slide 16. We have a total of 61. So if we finish, like, say on Thursday, we finish early with the lecture, then the rest of Thursday and Friday, you can actually be working on Alex. But idealistically, you want to be working on Alex on your own. Does that make sense?
So like how do you monitor it? Like how does that
So
work?
Alex is online. It's whatever work you submitted is automatically going to be logged, and then Dr. Lamar is going to send me an update, a weekly update of how everybody's progress. And so whatever report she sends me, that's what I'm going to use to calculate our lab rate.
So like tomorrow from like 3:50 to like 5:05, we don't got no Zoom, right?
No, we're going to be in Zoom. We're still going to be here.
Oh, all right.
Yeah. We're still going to do our Zoom sessions. Yeah. Okay, guys. If there aren't any other questions, I'll see you next time.
Get them off, Professor.
Go ahead. All right, take care.
You, Professor.
Yep.